Okay, welcome everybody. Today we're going to be talking about how to solve some radical equations. So first thing we have to talk about is called the principle of powers. Principle of powers. Sounds scary, sounds complicated, but really it just comes down to if we have something that equals something else, then if we raise both of those things to some power, it's still going to be a true statement. So if a equals b, then a to the nth power is going to be equal to b to the nth power. And we're going to use this idea to solve these radical equations. Okay? So let's take a look at the first one. So our goal is going to be to isolate the radical expression, or a radical expression, isolate the radical expression, use the principles of powers, solve for the missing variable, and then check the solution. Again, just like yesterday, I'm going to do all these in different colors, so hopefully it will be easier to follow. So first we want to isolate the radical expression. So if we take a look at this particular term right here, this particular expression, we want to be able to get this guy on one side by itself. So we want to get it to a form where we have square root of some stuff equals some stuff. So then x minus 5. Okay? And so in order to undo a square root, we need to square it. But if we square one side of our equation, we have to square the other side. So we're going to use that principle of powers to do that. So then we say, all right, square root x plus 7 squared equals x minus 5 squared. Now this is important. We have to do the entire side. We can't just pick and choose things to square. So the square and square root on the left are going to cancel themselves out. X plus 7 equals, and then we're going to have to resolve this. So remember that something in parentheses squared is equal to x minus 5 times itself, x minus 5. And you have to distribute. You can't just square both of those things. It's going to be bad news bears if you do. So we have used that principle of powers to square both sides, and now we are going to solve for that missing variable. So let's go on to number 3. Where we now say, okay, x plus 7 equals x times x gives me x squared. X times negative 5 gives me negative 5x. Negative 5 times x is negative 5x again. And then negative 5 times negative 5 is positive 25. So then we have x plus 7 equals x squared minus 10x plus 25. Now, whenever we have any kind of squared stuff happening, anything like this, we want to make sure that we are solving this like every quadratic we've solved up until this point, where we want to get everything equal to 0, and then we use one of those force solving methods to solve it. So I'm going to go ahead and subtract x plus 7 from both sides to get 0 on the left. X squared is going to stay what it is. We're going to subtract another x, so minus 11x, and then we're going to subtract 7 from 25, and we're going to be left with plus, let's see, that would be 18. Yeah. So now we need two numbers where our goal is to say, first off, do they have anything in common? They don't. Then, do we have two numbers that, if the number in front of x squared is 1, then we can just split it into x times x plus or minus something times x plus or minus something. In this case, we need two numbers that multiply to be 18 that add to be negative 11. And those numbers are going to be negative 9 and negative 2. So we have this guy equals 0. 0 equals x minus 9. Since we have factored, we now need to say, all right, I have this thing here times this thing here, and those two things multiply to be 0. What are those? The only way that can happen is if one or both of those things is 0. So we have to check and see what values of x make that true. So 0 equals our first parentheses, x minus 9, and then 0 equals our second parentheses, x minus 2. Adding 9 to both sides, we get that 9 is equal to x, and we also get that 2 is equal to x. So now we need to check and see if either of these solutions are indeed true. The way to do that, we are going to plug this back into our original problem, and we are going to see if we get a true statement. So 5 plus the square root of, whoopsie daisies, that's way too big a square root for my purposes, x, or 5 plus, our first x is 9, so we'll check that, plus 7 equals 9. So let's see, 5 plus the square root of 16 equals 9. 5 plus 4 equals 9. Cool, we did it. So far, so good. So now we need to check to see if 2 works. Let's see, 5 plus the square root of 2 plus 7, does that equal 2? 5 plus 2 plus, yes. So 5 plus the square root of 9 equals 2. Good. We're checking. So then, 5 plus the square root of 9, 5 plus 3 equals 2. 5, so that is saying that 8 equals 2. So you might be wondering, when we checked, well, we've been going over like the square root of 16 being plus or minus 4, and like the square root of 9 being plus or minus 3. I want you to, when you're checking, just for checking purposes, always take just the positive version. So like we always just want the positive 4 or the positive 3. And then if this would be like a minus sign, make sure you take and subtract that thing. Without getting into more of an explanation than this video needs, when you're checking your solution, take just the positive version of the square root. Just the positive version of the square roots, okay? I'll talk about that more if you want an explanation, but for right now, just take my word for it. When you're checking, just the positive versions of the square roots. Okay, so let's take a look at another problem. Similar, but a little bit different, and looks like this guy. All right, the rules for this are exactly the same. Isolate the radical expression, principal of powers, both sides, solve for the missing variable, check solution. Okay, so we have to isolate the radical expression. However, hopefully you have noticed that there are 2 radical expressions here. What I need you to do is pick your favorite. Pick your favorite radical expression. All right, get that one by itself. All right, doesn't matter which one you pick. Just pick your favorite. Get it by itself. I'm going to pick x minus 3 just because it's here. X minus 3 plus, or excuse me, equals 4 minus the square root of x minus 5, or x plus 5. So now we have gotten the radical expression by itself. Okay? Then we are going to move into the principles of power side of this, where we take and we square both sides. So we do square root x minus 3 squared equals this thing, 4 minus square root x plus 5 squared. Okay? So then from here, we need to expand these. When we expand these, we get something that should look like this. Now let's get a little more room to work, shall we? All right, extend the page. Let's expand some stuff. So the square root of something squared, square root's going to go away, and the square is going to go away. We're left with x minus 3 equals. This is parentheses 4 minus the square root x plus 5 times 4 minus the square root of x. Move out of the way, please. Thank you. 4 minus the square root of x plus 5. All right, when we multiply these together, 4 times 4 gives us 16. 4 times the negative square root of x plus 5 is negative 4 square root x plus 5. And then we have another one, negative square root, or negative 4 square root x plus 5. And then negative square root of x plus 5 times the negative square root of x plus 5 is going to be positive x plus 5. Because it's the square root of the thing squared. Negative times a negative is going to be a positive. All right. So then from here, let's clean up a little bit. We get x minus 3 equals, let's see, 16 plus 5 is 21. Plus x minus 8 square roots of x plus 5. Okay? So, that's where we're at so far. Now, since we still have this square root guy here, we need to circle back up to number 1 and isolate the radical expression again. So we're going to go back into blue, or 1 part B, and we're going to say, okay, we're going to get that radical expression on one side by itself. So we're going to take x, subtract an x, we're going to get, that gives us 0. Negative 3 minus 21 more is negative 24, plus 8 is negative 16. Right? I think. Come on, brain. Yeah. Write it out. Write it out. When in doubt, write it out. X minus 3 minus x minus 21 plus 8 equals the square root of x plus 5. Okay, so then we have our x's. These are going to go away. X's go away. Negative 3 minus 21 is negative 24. Negative 24 plus 8 is negative 16. Okay, I oopsed. I messed it up. Sorry. My bad, my bad, my bad. Okay, so what I did was this 8 right here is attached to this. They're multiplied together. I should never have subtracted that. That was bad news bears. Should not have done it. So then that equals 8. Sorry. Ugh. Thanks, brain. Negative 24 equals 8 square root x plus 5. Our goal is still to get this square root by itself, so we need to divide both sides by 8. We get negative 3 equals the square root of x plus 5. So then from here, we principle of powers again. So 2 part B. We principle of powers again, square both sides. We get that 9 is equal to x plus 5. Subtract 5 from both sides, we get that 4 equals x. Okay. Once we have that, whoopsie daisies, that should have been a different step. Step 2b is principle of powers. Step 3, get the variable by itself. Here we go. Subtract 4 from both sides, we get 9. Excuse me, 9 minus 5 gives us 4 equals x. So once we find that, we then need to check our work. So we need to back into the original equation. We have the square root of 4 minus 3 plus the square root of 4 plus 5 equals 4. Square root of 4 minus 3 is 1. Plus 4 plus square root of 4 plus 5 is square root of 9 equals 4. Square root of 1 is going to be 1. Square root of 9 is going to be 3, which is 4. Question mark, question mark, question mark. 4 equals 4. It works. Happy face. And joy was had throughout the land. Okay? So, that's the idea. If you have multiple square roots, you'll have to circle back and do those first couple steps again. But once you get rid of the square roots, it's all exactly the same. Okay? So, using those ideas, I would like for you to try this one on your own. Try this one on your own, and then pause the video and come back, and I'll have a solution for you after you have paused the video. Okay? Go ahead and pause right now. All right, we're back. So here's what I've worked through. All right, this is one path to work it through. If you ended up moving the square root of x over instead of square root of x minus 5, absolutely fine, no big deal. You just have a little bit of different path to success than I did. That's okay. So what we did, step 1, our goal was to isolate the radical expression. So I picked this radical expression right here and got it by itself. So then we use the principle of powers to square both sides. Square both sides, and when squaring this right side, remember we need to distribute. So when we distribute, 1 times 1 gives us 1. 1 times the square root of x plus x minus 5, gives us the square root of x minus 5. Square root of x minus 5 times 1 gives us the square root of x minus 5. And then the square root of x minus 5 times itself is it's squared, so the square and the square root will cancel each other out, leaving us with the thing underneath the radical, or x minus 5. Combining like terms got us to here. So 1 minus negative 5, or 1 minus 5 gives us negative 4, plus just the x, and then we had 2 square roots of x minus 5. So that's how we got to here. Since we still had a square root in part of our equation, in part of our statement, we wanted to make sure to get that square root by itself. We circle back up to number 1 and say isolate the radical expression, isolate the radical part. So adding 4 over to both sides gave us 4 here, and then subtracting an x from both sides made the x's go away. Now, in the last two problems, this has happened. Okay, in the last two problems this has happened. It's not always going to. Okay, please don't assume that that's going to happen. It won't always. If it doesn't happen, you'll treat it like it should be. When you square both sides, you'll end up needing to distribute instead of just squaring a number. All right, and then the 2 times the quantity, 2 times the square root of x minus 5 is left as 2 times the square root of x minus 5. I didn't mess up this time. Go me. So then, this 4, we wanted to get rid of this 2, so we needed to divide both sides by 2 to get square root of x minus 5 by itself. So then we principle of powers again, so 2 squared, and then square root of x minus 5 squared. 2 squared gives us 4, and then square root of x minus 5 squared gives us x minus 5. Okay. Once we have that, we now no longer have any square roots, so we don't need to circle back up a third or fourth time. And now we can say, all right, let's solve for x. Let's get x by itself. So we added 5 to both sides. 4 plus 5 gave us our 9. 9 equals x. And then step 4, we needed to check, whoopsie daisies, I left off the 4, how embarrassing. Step 4, we needed to check. So everywhere in our original equation where we saw an x, we plug in our answer and we get the square root of 9 minus the square root of 9 minus 5 equals 1. And we're not sure if that's the case, so we need to make sure that we are checking for that, not just stating it as a fact. Square root of 9 is going to be 3. 9 minus 5 is going to be 4, so then the square root of 4 is 2. 3 minus 2 is indeed 1. So 1 is 1. It works. We're happy. Yay, we did it. Okay? So that's it for today. I'm going to go ahead and stop talking now, and you guys can go ahead and get started on your assignment. I will see you later today if you are around, and have a good one. If you have any questions, come find me. I'll be happy to share. Have a good one. Bye, guys.